So what we want to do now is practice with graphing a rational function that has horizontal ends or end behavior. Okay? And so the directions might say something like, the techniques we're going to use will be using end behavior, graph using end behavior, zeros, and multiplicities, which results in a kind of a sketch of the graph, not terribly precise, but that's what we'll be using here. The function we'll be graphing is f of x equals x cubed plus 4x squared plus 3x all over x to the fourth minus 8x squared plus 16. Okay? And so to get started, what you should try to do is see if there's any use in this version of the function. And in fact there is. Since it's not factored, it's very easy to identify the leading term. So see if you can identify the leading term from this guy. And then once you got your leading term, go ahead and graph your end behavior. You know, your left end and your right end. When you think you've got that, come back and check it out, see what you get. So your leading term should be 1 over x, which means your end behavior, make sure you get it before I do, should look like this. Okay? So that's what is easy to get when the function is not factored. So now you want the zeros and multiplicities, so you need to factor the top and factor the bottom and rewrite your function, okay? So pause the video and go factor the top all the way, factor the bottom all the way, and then come back to see if you factored correctly. Okay, when you factor the top, you should get x times x plus 1 times x plus 3. When you factor the bottom, you should get x plus 2 squared times x minus 2 squared. Okay, so if you had any trouble factoring, go back and see if you can figure out how to get those answers. But once you've got it factored, then you know your zeros and multiplicities. So go ahead and start setting up your number line chart here, your x number line chart. Cut your number line chart at let's see, we've got 5 zeros, so cut it in 5 places. And go ahead and write the multiplicities beneath each of the zeros as well. Those will come in handy. So pause the video and find your zeros and multiplicities, label those. Once you've got your zeros and multiplicities, see if you can figure out the y value for each of those zeros. In other words, if you plug in one of the x values to the function, it's probably easiest to plug it into the factored one, by the way. It will work on either, but the factored is probably easier. Plug in each x value to the function and see what you get for y, and then write those values in above each zero. Then you've got to figure out the signs between each of your zeros, right? So you're going to start by using your end behavior to determine whether y is negative or positive on the left end and whether y is negative or positive on the right end. Okay? Then you look at your multiplicities, whether they're even or odd, to determine if these signs are the same or different. And you work your way all the way across to figure out all of the same and different signs based on your multiplicities. Alright, so that's enough information to get you going on your number line chart. Go ahead and pause the video, see if you can fill out the whole thing, and then come back and see if you got it right. Okay, so our zeros are -3, -2, -1, 0, and 2. The multiplicities are 1, 2, 1, 1, and 2. The y values at each of the zeros are 0, undefined, 0, undefined, sorry, not undefined there, 0 here, and undefined here. Okay? Pause and correct your errors as you go here so you can figure out where you went wrong. Now we'll work on the signs in each region. Working left to right should be negative, positive, positive, negative, positive, positive. Okay? So get all caught up to this point, make sure you understand all of it, and then we'll translate all of this information into a graph of the function. Okay, so go ahead and set up your graph. Here's 0, here's 2, let's say this is -1, -2, -3. Determine whether each of the zeros results in an asymptote or an intercept based on your number line chart, and plot those. So draw your asymptotes and intercepts. Then draw in your end behavior on the left end and the right end. And finally, use the signs in the middle here to determine the behavior of the function between your zeros. Okay, so pause your video. Try to work through the entire graph. Take your time. It takes some practice to get quick at this, but once you get it, it's not bad. And then come back and see if you got it right. Okay, so at -3, we have an intercept. At -2, we have an asymptote. At -1, an intercept. At 0, an intercept. And at 2, an asymptote. The left end does this, and the right end does that. Then to the left of -3, my y values are negative, so my graph comes up and then it reaches 0 here at -3. Between -3 and 2, my y values go positive, so I have to go above the x-axis, but then I have to approach my asymptote. Between -2 and 1, my y values are positive. Sorry, -2 and -1. My y values are positive, so I'm above the x-axis, deflecting up near the asymptote. Between -1 and 0, my y values are negative, so I have to dip below and then come back up to 0. Between 0 and 2, my y values are positive, so I have to be above the x-axis, but I have to deflect up as I approach my asymptote. And then past 2, my y values are positive, so I have to stay above the x-axis, and as I move this way, I have to approach my asymptote. So that's the graph you should have gotten. If not, rethink what could be wrong with yours. Common mistakes here are just stopping your graph. These graphs don't stop. They get infinitely close to these vertical asymptotes, okay? So don't be scared of those. You're either going to deflect up or down near the asymptotes. But that's how you graph a rational function, and in this case, where the ends are horizontal.